Hi all, let's get into deeper into K maps and we will try to understand how it can be solved easily and it's a very smart huge topic and you guys need to understand it very carefully considering the examination point of view also. So and let's go into the deeper now. So here you can see we are trying to have a uh, for variable key map here. So what happens, how we need to start grouping. So this might be everyone might be having a doubt in their mind, so always we need to start a grouping with highest number of possibilities. That means if we take four variable key map, highest possibilities will be hexa. That means 16 possible combinations can be grouped once. No, we don't have. Then we need to start with the octet, means 8 grouping combinations. 8 grouping combinations do we have? I need to verify it. No, we don't have. Then we need to start with quad. So quad will be having, in quad we as you all already know that, so four combinations, four possible combinations we will be trying to group it together. Yes, here you can see we are having this one as a four combinations and this one as a four combinations. Yes, it can be grouped as a two quad here, and that one we have marked it here. And also, is there any other possibility or ones we left with? Yes, we are left with these two, and these two can be grouped as a pay here, so that it will not be over repeated here. And then you guys might be having a doubt, saying that, so there might be some jugaad kind of a questions. I can say you guys might be having a doubt, like we have a two quadlet right here. This one is this one and this one and this one. Can we group it two, and can it be considered as a single octet? No, it can't be done, because always while grouping there might be some of the rules that you may be learning in future classes, that how it can be done. So always it should be adjacent to it, and always it should be a vertical. And you can't group something like, suppose if let's assume that you have one here and you have a somewhere, let's try to hand and just I'm trying to find a very easy one. So let's assume that I expect, don't consider the remaining terms here. Let's consider that we have one here and only one here. Is that can be grouped like this in the horizontal? No, it's not possible for this. Only for the corners we have. And based on this, here you can see these are the simplified terms in the these are the simplified terms by using the K-map. And let's go into the we will try to understand some of the rules that we may have, or just we need to consider while doing it. Zeros and ones, no, never. It's a wrong thing if we group like this. Albert should be start with only single term. So okay, here you can see this is the right thing, and I previously said already. I have explained it already. This is wrong thing. This is the wrong thing. In the diagonally, it's not possible. It's not recommended to group it. And also here, if we have a three ones here, it can be grouped like this. And you guys should remember always these rules, like how it works. Okay. A group must contain always, yes, and this is the very simple and interesting thing to remember it very easily. 2 to the power of n cells. So 2 4 1 2 4 8 16 32, in that manner only we have to always we need to be do the grouping of it. Okay, so I think you guys already remember that here. So this is the right thing because these are two adjacent, and this is wrong thing because this is a tree, and the tree we are not supporting it here. And this is the group of 4. So yes, we are supporting it here, and this is wrong. Why this is wrong? This is octet, but why it is wrong? Here you can see we are trying to consider, here we are trying to group these zeros also. This is not at all acceptable. How this can be grouped? This can be grouped like this with the one quad, and with the one pair it can be done like that. And this is also one of the easiest thing. As I said, you might got confused like why this is right, why this is wrong. So already in the previous session I already have explained you guys that first always we need to start with the maximum number of groupings. This is also right, but what happens, we have a possibility of grouping 4, but we have ended up only grouping 2 2. This is not the right thing. And here also you can see this is, even this can be grouped as a 4 also. Here you can see completely, so it's easy to understand. And this is the one more thing. So each cell containing a one must be at least a one group. Suppose if you have left with no combinations, you can group one as an individual combination itself. It's not a problem. So overlaps group can also be considered, and we have already seen it. Okay, we have a possibility of having 4, but we're not considering it here. Always we need to have a 4. And how it can be done? Yes, it can be done in 4 ways. Here you can see like this. If you fold it, so it can be grouped as a pair here. That's a one thing. Or it can be grouped as a quadrat here. So always we should try it for maximum number of possible combinations. And rolling the map, yes, if you roll it down, suppose if you roll it down, so this will come on top of this. And also, so that what it can be done, just it can be it can be grouped like this. And let's try to understand, let's try to simplify it. Even though if you do it, you will get a two terms, right? What are that? B C bar D bar and B C D bar you will get at the end. Suppose let's assume that how it can be simplified, it how we will get at the end. So here you can see B is a common, we will take it up, and D bar is also common, we will take it up. C and C bar, it is represent C A plus A bar equal to always 1, and the same way C plus C bar equals to 1. That means we will end up with B D bar. This is only right, so B D bar, same, right? That's it. So even it can be simplified like that also. Instead of grouping as a one as an individual element, so you have a possibility of grouping two, right? You should be considering this one as a two. So that's why use one as a more than one to get a largest group. Yes. Instead of if you give a one if you group as a single here, what happens? You need to enter a 4 terms here. Instead of that, if you create a pair, it will be having a 3 terms. So it's an added advantage. So and the number of outputs can and the number of variables can be reduced with the expression. And already we have seen this example. There should be as a few groups as possible, as long as this could not contradict any previous rules. Yes, so this is a good practice that we need to follow. So rules that we have to see it here. Zeros are no zeros allowed. No zeros allowed in which conditions? Only in sum of products. In products of terms, always we will be grouping as zeros only, but most of the times we'll be dealing with sum of products on that condition. Zeros are not allowed, diagonals are not allowed, only the power of 2 number of cells in the group, that means 1 2 4 8 16. Group should be as large as possible, that means we need to always start with the large groups. Everyone must be in at least one group. One should not be left out, at least it should be considered only at least once. Okay, overlapping is allowed, we have already seen it in the previous. Wrap around is allowed, as we have already cornered 4 corners, right? So that is also allowed. If possible, roll up and overlap to get a largest groups, you can find it. We have seen it in the previous examples already. Fewest number of groups are possible, that means we should not create duplicate groups, and always we should try to have minimum number of results at the end, that means simplified results at the end. That's what we need to do it, right? So these are some of the already rules we have already started with. Here you can see we can have an option of 8 and 2 here. So the result is C bar, this all cancels out, and it is, here you can see A bar cancels out, it's a B, and CD bar. Okay, instead of doing this, we have one more possibility. Here you can see this, instead of grouping 2, what we can do, it can be grouped as a 4 combining this, right? Yes, that gives one more less variable at the output. So always you should be thinking of big numbers. Okay, map examples 2, let's try. So how it can be done? Yes, this is a very critical. It is a very typical exam kind of a questions I can say you will get at the end. So is there any idea like how it can be done? I think still it can be done. It can be done in a three groups. Yes, it can be done in three groups. How? This is one octet, right? And all the fours can be covered. All the fours, and we will cover these with these two, so that we'll be having only three groups. But look at the number of output representation that we had. Here they are trying to cover it as a pair here, but here you can see we will end up with the one hexa and three quad number of output. Come, just take a compare of this one. How the number of inputs are getting reduced. Okay. Okay, a group whose ones are already used by other groups. Okay, we'll try to get one more example here. So yeah, this is one classic example. Most of the times you will come across. Okay, here you can see instead of doing this, no, if you observe this one, there is no possible that uh, a quadrant can be considered by expect these four. So instead of that, it will be always good to have a pair of fours only, right? With having four pairs on one quadrant, or quadrant can be eliminated like this. Okay. Enter one for the Karnaugh map formats. Karnaugh map for each fundamental product that produces one output in the truth table and enter zero elsewhere. That means we should have always one. We should enter one where we have a output for the particular combination of the input. Encircle the octet quadrants and pair. Remember the role and overlap to get a largest group. Always we should start with the largest group itself. If any isolated as a ones remain encircle each, no one should be left out of the no combination should be left out. Eliminate any redundant group. Write on the Boolean equation by ORing the product of corresponding encircled group. Just they are expecting what is the simplified Boolean expression for the following. So any ideas? Anyone is looking? Anyone? Like this, it can be done. This is acceptable by. This is acceptable. Why? Here you can see. This is one, right? This is independent. This is independent. This is independent. This is independent. Those are not covered. That means all the four are correct only, because all the four are covered, are having at least one identical term. So it is a valid only. We will try to simplify these results, how we will get. So here you can see, suppose if we put these results into the K-map and group it in K-map, it will be displayed like this, and if we group all together, we will be getting these results. Okay. Don't care conditions 3. So don't care always like a very helper guys in while doing solving. So if we consider it can be grouped as only one. Instead of that, here we have option, here we have option. Two pair can be grouped. If we observe that we have option of grouping in the quad itself, then why should we leave? And we will consider this remaining 3 and we will left remaining 3, so that the expression is AD instead of having a 4 numbers. And whenever a don't care is condition, whenever a don't care condition is given, so we will try to write with the K-map with the don't care conditions, and we will try to first we will try to have a look into all the possible ones here. So and using the don't care conditions, we will try to encircle maximum possible group in that. After actual ones has been included in the group, discarded the don't care, visualizing them as 0. So we need to consider it. Can you guys try this one? We are having only one for this particular combination. Okay. And the remaining are don't care conditions. Is that can be simplified? It can be simplified in only one way, by folding this one with this here. So what is the expected result here? So and also it can be written like this also directly instead of simplifying it. They have tried to obtain directly as a ABCD bar, and this is the expected some expected logic circuit that they wanted. Get that. Don't care conditions. Once again, we have many here, and what is the output? Don't care condition. We have like this. Only a pair can be entered, and remaining can be eliminated. What is the just here? You can see A bar cancels out. B will stay. Yes, B is there, so B will stay. And CD directly we are trying to have it, and output Y will be displayed. Determination of minimum expressions using essential prime implicants. Any single one or any group one which can be combined together on a map the function of S. Suppose if we have some functionality, and how it can be done. F represent a functionality, and that once represent a particular function as a high in that. A product term implicant is called as a prime implicant if it cannot be combined with another term. Yes, prime implicant. Yes, we'll come across prime implicant now. Prime implicant, what happens? Suppose we have some of the terms, okay, where it will not combine with any of the other term to eliminate some other different variable. That time we will be calling it as a prime implicant one. We will try to understand it while going in future. Here you can see what is the prime implicant. We will try to understand what is the prime implicant, and how it can be, what are the prime implicants are here. Okay, in the figure, these combinations are a prime implicants because they cannot be combined with any other two terms to eliminate a variable. Where it is a bar, b bar, c, this one, because you can see this is not combined with any of the other term, and a bar cd, bar, these two, because even though they have a shared variable, but this one what's happening, this is not a prime implicant, because what happened, why it is sharing this with this to get eliminate some variable, to get variable d as a variable. Okay, so to do and so that we will be calling this one as a prime implicants, and even this one will not be a prime implicant because it can be combined with, and it can, these two cannot be combined with any others. These two cannot be combined with any other, so it will be, it's like a prime numbers you might be knowing. A number which divide itself by itself with the and with one, it will be called as a prime number. In the here also you can see a combination where it cannot be grouped with any others, so it will be called as a uh, prime implicants. Here you can see this one, what we can do, it can be configured with this, it can be configured with this, so this will not be a prime implicant. Neither ABC or ABC is a prime implicant because it can be combined with the A and C. Here we have a two combinations, right? So these two can be combined single as a one, right? So this will not form a prime implicant. All form of the prime implicants of a function can be obtained from the Karnaugh map. Okay, a single one on a map represents a prime implicant if it is not adjacent to any ones that we have already discussed. Two adjacent ones on a Karnaugh map are a prime implicant if they are not containing any of the group of four ones. Suppose if any of the combination of pair is not implicating, if it is not combining with any of the other quad or something, so it will be called as a prime implicant pair itself. Four adjacent ones form a prime implicant, they are not contained with any of the eight ones in group of eight ones. Determination of minimum expressions using expression. So now we will try to understand essential prime implication. Okay, The minimum sum of products expression for a function consists of sum of the prime implicants. Some might be having, some might not be having. In other words, sum of products expression containing a term which is not a prime implicant cannot be a minimum. Sum of products expression containing a term which is not a prime implicant cannot be minimum. Suppose a term which is a minimal, but there might be also chance that it cannot be a prime implicant because it may shade some of the its may shade some of its implicant some of its combinations with the other groups also. This is true because of the non-prime term were present and the expression could be simplified only combining non-term term by additional minterm. I will try to understand it in next slide. So the functional plotted in the figure 6 has 6 prime implicants. What are those 6 prime implicants? 3 of these prime implicants cover all ones on the map. 1 minute. So this will be a prime implicant, this will be a prime implicant, right? And there should be one. And minimum solution is the sum of all these prime implicants, etc. The shaded loop represent the prime implicants which are not a part of minimum solution. Yes, this one can be eliminated. Here you can see this one can be eliminated. Even this can be grouped in different ways. This can be grouped in 4, this can be grouped as a 4, this can be grouped as a 4. And here you can see how the prime implicant can be formed. So here you can see here in the representation there is some dotted lines as well as covered lines. Okay, here you can see whatever the prime, how the prime implicant can be formed, it can be explained by the straight line, and how the non-prime implicant can be formed, it's explained by using dotted lines. If you see it here, this one is there, right? It's a complete and it not shares with any other one. Just we'll try to have it with the shaded one directly with the without having to shade it. Here you can see, just follow my cursor line here, this one and this one. And here you can see these are not shared with any other groups here. That means these are prime implicants only. But how this will become a non-prime implicants? Here you can see, suppose if we do like this dotted lines, we have, right? If we do like this will become a non-prime implicants. Okay. All of the prime implicants of a functions are generally not needed in forming a minimum sum of products. A systematic procedure for selecting prime implicants is needed. We need to do it in a systematic way. If the prime implicants are selected to form a map in a wrong order, a non-minimum solution may, suppose if we are trying to combine all the things, we are trying to 1 minute. Suppose if we are trying to group in a wrong order, what will happen? A non-minimum term may result. So always we should try it for minimal term here. Here you can see this is once again if a CD is chosen first, where is here you can see if the CD is chosen first, then BD, where is BD? If a CD is chosen first, then BD and B bar C. Here you can see this is B and this is BC and this is CD. B, right? B where it comes. If the CD, this is CD, so this is the CD. If the CD is chosen first, then this is the BD. So and BD, B bar C, B bar C, B bar C. So this one B bar C, and AC, AC, and AC, this one, and AC, and needed for covering the remaining ones. And the solution contains four terms. Here you can see it would be having four terms. If the prime implicants are indicated in the figure B, chosen first, all ones are covered, and CD is not needed. Here you can see CD, we have covered it, right? It clearly shows that all the ones are covered in some other groups. Does it seriously require? Definitely not. How it can be eliminated? Suppose if you want to start, if we start doing grouping with the prime implicants, and we need to have some prime implicants, if we start with that concept, definitely this can be eliminated. Okay. And note that the minterms are covered. Here we are trying to have one more example. So note that some of the minterms in the group figure A are covered only by a single prime implicant, this one, but the other minterms are covered by two different implicants. For example, M2 is covered. For example, M2 is covered by only by B bar C, only covered by B bar C, but M5 is covered by B bar C and D, but M5 is covered by B bar and CD. Determination of minimum expressions using the essential prime implicants. If a minterm is covered by only one prime implicant, if a minterm is covered by only one prime implicant, that prime implicant is said to be essential prime implicant. Okay, if a term whatever we are referring, it is covered by, it's not overlapping with any other means, it will be essential prime implicant, and it must be included in the minimum sum of products. Always it exists. So okay, in the previous in considering the previous and okay map, B bar C is an essential prime implicant because M2 is covered only by other prime implicant. CD is not essential prime implicant because ones in CD are covered with any other by another prime implicant. The only prime implicant which covers M5 is BD, so BD is essential. So BD is essential. Where it comes BD, B, D. So this one will be a only essential one. And AC is essential because no other prime implicants cover M40. In the general, in order to find a number of in order to find a minimum sum of products from a map, we should start first loop all the essential prime implicants. First, we should always start looking for essential prime implicants. One way of finding essential prime implicants on a map is to simply look into one on the map. So, and that has already been not already covered. That means we should look into ones after putting into the K map where that one is not covered by any of the pair groups. Okay, there is only one prime implicant which covers only one, that can be prime implicant. That prime implicant is essential. If there are two or more prime implicants which covered one, which say we cannot say whether these prime implicants are essential. Now checking with the other minterms. Always it should have a single share. I think we are more to forward. Next we'll try to move to the next one. Here you can see M4 is covered by only prime implicant BC bar. Where is BC bar? Prime implicant BC bar. This one, okay. M4 is only covered by a prime implicant BC bar, and M10 is only covered by prime implicant A and C. This one is there, and this one is there. Only this can be done. Only these are called as a prime implicants, and also this one will become a prime implicant. All other ones are covered by these two prime implicants. Therefore, they are only essential. If the given min term and all the ones are adjacent to each other by covered by a single term, then it's an essential prime implicant. So already we know that essential prime implicant. If all the ones are adjacent to the given min term are not covered by a single term, then there are two or more prime implicants which cover that min term. We cannot say whether these prime implicants are essentials or without checking the min term. Always we should look into the min terms. Here also there is one more example. Adjacent ones for the min term M0. M0 are 1 to 1, 1, 4. So, sorry. Here you can see M0, 1, 0, 1, 1, 1 fourth, and 1 fifth. Fifth, which is present in these cells. The adjacent ones for the this one here you can see it's having some adjacent ones here because no single term covers all four ones. No essential prime implicant is yet apparent. So always this should become because we have a one possibility, only one possibility having a quad here. So it should be covered. The adjacent ones for one here you can see we may get one more here, 1 1 and 1 0, 1 1 and 1 0 or 1 5. So the term which covers AC is essential primary. The term which covers A bar C bar adjacent ones for adjacent 1 1 and 1 5. So here you can see, so this is the prime implicant, right? Whatever we are trying to have with a straight line. So here you can see, so this will become a prime implicant because it's not shared with any others. Here you can see. So it will become an essential prime implicant. So the only one adjacent is ABD is also essential. Where it comes A, B bar D. Here you can see this is also essential prime implicant because here you can see this is not shared with any of the other ones. So I love next we'll try to have 11 and 15. Here you can see this has been already shared with this and this has been just we are trying to have it independently. So it will also become a essential here. So and the overall what will become, so here you can see how it can be done. This one will be a essential. 1 minute. So one adjacent to I7 I5 is not covered by a single term, neither P or okay. One adjacent to I7 and I15 are not covered by a single term, neither ABD or BCD is essential. So even this will also become a essential. Okay, 1 minute to complete the solution. Okay. In order to cover this, Yes, I got this. Let me explain. We have one term here. We have these many terms. One, two, three. We have. In order to cover this one, it can be done in two possible ways. Okay. One, it can be considered by pairing with this, or it can be considered by pairing with this. Okay. So what happens is, so these three are common. Okay, we have it. So either this one we can take it up or this one we can take it up. So it can be done like this. So that's what we have written it here. And the following procedure can be used to obtain a minimum sum of product in the from the Karana map. Okay, what procedure we have to follow? Choose the minimum. Choose the min term a equal to 1 which has not been covered. First we need to look into the essential prime implicant, and we may need to look into the don't get terms if anything is there, so that it will be given, it will just try to give us a very simplify, it will try to give the simplified term of the results. If a single term covers a min term, all the adjacent x, and if we have a don't case along with that, so we will try to cover, we will not try to cover all the don't care conditions. We will try to cover only the required don't care conditions, and we will eliminate remaining don't care condition, remaining things. So we have to find this one until essential, all the essential prime implicants are found. So it just here you can see it's a flow diagram. Here you can see the same thing has been explained in the flow diagram. Choose the one which has been not been covered. Find all the adjacent ones and don't cares. Our chosen one is adjacent to the x covered by a single term. Yes, then that term is no an and the term is an essential prime implicant and loop it. Done. Yes. Then if all are covered, done. Then just find a minimal set. Then you stop it. Or if it is not ended here, just you need to repeat until all the possible combinations are found out. And you guys, just these are some of the problems on KMAP from VTU question papers. So you guys just try to go out, try to find out the results. So what is a simplified Boolean expression for the following logic expressed by min terms? And this is the question for you guys, and I will be sharing this one. Okay, and here you can see we have five questions here. So you guys try to please solve it, and the results are also given. And a few more are here with the don't care conditions, and here are some of the few more. These questions previously showed questions, you guys has to try it. Simplification using the map entered variable. Okay, one of the input variable is placed inside the Karna map. Okay, this reduces, we will try to have one input variable inside the key map, and this reduces the Karna map by 1 degree. Suppose if we have, okay, all the three possible combinations requires all three problem that requires 23 locations in Karna map will require 4 locations. Okay, this technique is particularly useful for mapping the problems with more than 400. Yes, what we'll try to have is, yes, we got. So suppose let's assume that till 4 variables we have seen. What if happens if we have more than 4 variables? There we'll try to have one as a common variable, and then in the, and we will split we will try to split that k map into a 2. You guys will try to understand now here. Example, let's see that. And this is a 3 variable k map, right? And here you can see this is okay, and we are trying to have it here. Hey, see, okay, 0 1 0 1. Just see, these things are common, right? These things are common, and we are trying to express it. These are complement to each other. Simplification using, okay, let's see C can be entered in the variable and see how we see it. Okay, for AB equal to 0 0 0 and Y equal to 0, it's not dependent on C, right. 1 minute. If you guys will try to understand once the kernel map is visible. So if choose A as a map entered variable, then write the corresponding entered variable. If this 1 minute, 1 minute guys, 1 minute. There's a slight confusion here, and we will try to understand. So for this 0 0, this is C bar. I got it. Yes. How it can be done? Yes. Here you can see AB we are trying to keep, and how Y will be represented in terms of C, and we will try to understand. So Y is 0 0. Y is 0 0 irrespective of the C when both the inputs are 0. Okay, it's 0 only. And here you can see we have a 1 when the C is 0, and we have 0 when C is 1. That means always Y will be inverse of this one, right? So here we have represented like this, and here you can see always irrespective of the input, it's always 0, so we are considering 0 only, and irrespective of this one always it's 1, and we are writing C here, C only. So how it can be done? So what we'll try to do, so now we'll try to have C as a variable, and we'll try to put the result. Only it has a 1 2 3 4 status. That means only 4 status are available. 0 0, here you can see 0 1 1 0 and 1 1 status are available. For these conditions we will try to have a result. So AB are the inputs. So AB we have taken it here. So and 0 0 combination we have 0 0 combination we have 0 0 1 combination 0 1 combination we have 0 C bar, and 1 0 combination 1 0 combination we have 0, and 1 1 combination we have 1. So this is how we'll try to have a EVM table. So and the same thing has been explained it here as well. If choose A as a map entered variable, write the corresponding entered variable K map. Here you can see. Suppose if we select A as a variable, then the result will be displayed like this. So with respect to the Y as an input, so for 0 0 combination 0 will come, 1 0 combination 0 will come. Sorry, 0 1 combination 0 will come, 1 0 1 will be represented, and 1 1 A will come. So if we consider this as an input, so A will be displayed like this. Okay, and if B is chosen an input, so we'll be getting the results as like this for the input 0 0 1 0 combinations. And this is very similar to the K-map, right? K-map method, right? Now what we'll try to do, so and already in the previous sessions you would have seen there will be a 1 and C, so we will try to combine that. Note that C bar is grouped with 1 to get the larger group as 1 can be written as like this one. This one we are trying to say it, the same one, right? The same we are trying to represent it here. This is what we are expecting it. Okay, so it will be a B C bar and AB. B C bar B C bar and AB. We'll have this one and this one as a single one. B C bar, okay. AB AB is okay. Okay, yes, I got that. Here you can see this is a complete term. B C bar, okay, and this is a one complete term, right? So AB is this one, this combination. For one also we are trying to represent it. The product term representing each group is obtained by including the map entered variable in the group as an additional and data. Okay, and which is this is nothing but we are trying to have A as a input variable, A as a variable, and we are trying to have BC as a input. Even the same applies here. Simplification using K-map entered variable. By using the map entered variables, Karnaugh map techniques can be extended to simply more than. Suppose if we have more than 5 input variables, which can be, that means what we'll try to have, let's assume that ABCDE we have. So ABCD what we will do, so we will have ABCD as a 4 inputs and we will try to have E and F as a variables here and remaining are don't care conditions. So this is one way of doing it here. You can see 6 inputs we have, so we are trying to do like that as we have did it in the previous example. Okay. This is how we do it, product of some applications. This one we should get at the end. Okay, and this is how we'll implement the circuit, complementary circuit. Yes, it's a complementary circuit and we are trying to represent it, and now we will be getting one more circuit here. And this is the result we are getting and we are trying to represent. If anything is asked in a question to write a complementary circuit, then first you need to do the simplification, then you have to group that, and then you should start writing the expression circuit for the expression whatever you have received. Okay, suppose let's assume that it's a pos. Okay, products of sum, there already I have explained that we need to group zeros instead of ones there. So this is the one of the such kind of examples and results, as you might be already knowing that. So here it will be represented in terms of using products of sums. It is the same with here we are trying to use with don't care conditions also here. And this is one more example where we'll we can have it for here directly 1 2 3, so 3 groups we can have it. Okay, and these are some of the questions that has been asked from the pause. Okay, and this is one of the very important, and you guys need to work a lot on K-map to get it understand it very clearly. I hope you guys will do that. Okay, and I wish you all the best. Thank you.